All right, so this is an introduction to JavaScript class. These are always a lot of fun. So let me go and cover a couple quick basics at the top of the class here. Not the least of which is, who the heck am I? And why should you even care what I say? So my name's Erik Gross. I am the co-founder of the Tech Academy, a software development bootcamp based out of Portland, Oregon. And I've been a senior level software developer. That doesn't mean anything specific. It just means that I've been doing this for a long time. It's not like there's an official ranking system for software developers, but I've been a software developer and technologist for a long time. I've got a technical background that goes back in terms of my actual, career proper, to the late 80s, early 90s when I was in the US Navy. And even earlier than that, I was coding when I was 11 or 12 years old. I love computers, big old nerd. So that's me. A couple quick rules about how we run these classes. We have a class assistant, Regina. If you've attended before, you're probably familiar with her. She's awesome. She works behind the scenes, and her role is to monitor the chat, answer questions, and in general, just make sure these things run very smoothly. And she's very helpful in that regard. Please be very nice, both to her and to everybody else in the class. Regina will remove you if you're a problematic student. I haven't had anything like that in a long time, so I'm not really too worried about it. I do want to stress that these coding classes that we run, they're designed to be introductory classes. And we feel pretty comfortable that we've done a decent job of making them introductory in nature. Now, that said, they're still going to be challenging. And part of that is the nature of the beast. Learning to enter instructions into a computer to make it do what you want it to do is a bit of a challenging concept. We do a lot to make it simple and approachable, but just expect to be challenged a little bit. You will have a chance to get your questions answered, but expect to be challenged a little bit. One of the biggest things I can tell you right off the bat that'll help with whether or not this is really challenging for you is that whenever I'm writing code on the screen and asking you to write it, don't hurry and write it exactly as I've written it. One of the things that's like built into the nature of a computer is that they rely on exact patterns of text. And when you're writing your code in, if you haven't provided an instruction to the computer exactly as it expects that instruction to be formatted, it won't know what to do. It can't work with it. And so something as simple as, a punctuation mark in the wrong place or forgotten, or something that should be capitalized only being in lowercase. These seems like little things that can actually stop your program from running. So just pay attention when I'm writing and write it exactly, and that'll usually handle most issues you'll run into. Another big thing, if you're attending on a mobile device, which happens every once in a while, if you're attending on a mobile device, probably not going to be able to write the code. It's not going to work that well on a mobile device, but you can listen, and I encourage you to stay and listen. Because while the maximum value can be gotten out of these classes by actually getting your hands dirty and writing the code, the fact is we're going to go over some fundamental concepts related to computer programming that are very, very valuable. And you'll learn those even if you're listening on a mobile phone. Cool thing is you can still watch the full event afterwards. We put them up on YouTube. And we're going to provide you with the full code of the game that we're looking at tonight. And so you'll be able to go through the class on a full size machine later. So do stick around if you're on a mobile phone. Another real big thing, please make sure you're working in a distraction-free setting. It takes mental effort and clarity to get through some of this stuff. You don't want to have a real noisy or distracting environment. One more note on that. If you fall behind, when we get to the coding part, if you fall behind, don't freak out. It's okay. Just pause. Don't worry about following along with the code anymore. And just pay close attention to what I'm teaching, because it's kind of like the thing with people on their cell phone. There's super valuable things we're going to impart that, yes, it'd be great if you were able to follow along with every step and do all of the code, but you're still going to learn a lot, and you'll be able to pick up the video later on and go through it at your leisure. So if you fall behind, don't worry about it. I've already said it a couple of times. These classes, we do put them up on YouTube. It'll be later today or tomorrow. We're usually pretty quick with the turnaround. We'll provide links to all of our YouTube channels and everything later on. And as I've said before, you will get the full code to the program at the end of the class. You'll be able to go through it at your leisure. Lastly, there's going to be a lot of links to future events, free videos, other resources we'll provide at the end of the event. So stick around for that. All right. So we have a chat. We also have a Q&A function in this version of Zoom. Do not use the Q&A. Just use the chat. Regina and I are monitoring it at all times. Well, Regina's monitoring it at all times. I get carried away doing the teaching, and sometimes I don't notice things in the chat. That's where Regina comes in super helpful. What I'd like to do right now, just because I so enjoy it, if you haven't already, pop into the chat and just let us know where you're joining us from. Where in the country are you joining us from? Put that in chat right now if you haven't already. Malala, Oregon. Hot dang, that's fantastic. I know exactly where that is. We got some Vancouver, Washington going on, Denver. I think it's Leominster, Mass. I'm not sure how to pronounce that one, that bad boy. Colorado, Charlotte. People all over the place. This is great. And we got some people from Portland, Oregon. I lived there for 30 years. Love it. Louisiana. It's exactly where I am right now. We are getting ready for a severe cold snap tonight. I had to do a bunch of prep work on the house. We thought we were out of the woods with the cold we had a couple days ago. Nope. It's coming back with full force. I actually had to repair a broken pipe today. Felt all manly. All right, good. Thank you. I'm glad to see you're all here. Got somebody. Oh, we got somebody from Toronto. That's awesome. Hawaii. I lived in Hawaii. In fact, I lived in a town in Hawaii. I think you all love this. This town, the name of it is all vowels. It was Aiea. And whoever it is that's joining us from Hawaii is probably very familiar with this little community. It's called Aiea. And I just got a kick out of the fact that it was a whole town, no consonants, all vowels. All right. I'm glad you're all here. Yes, we'll put salt in the driveway and onion powder and Tony's. Tony's is a really popular Louisiana seasoning. All right. I'm glad you're all here. Let's talk about the basic agenda today. We're going to have a short intro to the Tech Academy. I won't spend a lot of time on that. I want to get right into the coding. And the coding is fun. Now, again, I'm going to try to go to decent pace, give everybody time to follow along. Again, if you get, behind, don't worry about it. Stick through it. When we're done with that coding, you're going to learn some really, really cool, important things about coding. And not just about coding, but about computers and about the industry. And I hope you'll find out for yourself whether or not you even like this activity, whether or not it seems like technology might be for you. It's one of the main purposes we have for these classes is for people to get an opportunity to find out, is tech even for me? Like, let me do some of it. Let me do some of the actual activity and find out whether I like it. Now, I do want to clarify something. Here's a special bonus, okay? One of the visions that people have of being a computer programmer or software developer, or whatever, job title you have, one of the visions people have is that it's all about writing code all the time, sitting at the computer and constantly entering instructions in. Nothing can be further from the truth. Most computer programmers may spend 25 to 30% of their time actually writing code. There's a lot more you do. We'll get into that, by the way, in a class in the very near future about a day in the life of a developer, which I highly encourage you to attend. But I want to stress this for two reasons. One, it may sound silly, but we've heard it often enough that I do want to address it. We get questions sometimes for people who are interested in breaking into tech, and they're like, I can't type really fast. Is that going to be a problem that I don't have a really good typing speed? Having been in the industry for decades and being a very slow typer, that one really makes me laugh. But after I got over laughing really at myself, I clarified, and I'll clarify to you now, you will never need to type fast as an engineer. It isn't a matter of how fast you type. It's a matter of knowing how to think like a computer, knowing how to think like an engineer. And no matter how quickly you write it, writing effective code to solve a problem. Speed isn't the issue. Effectiveness and value are. All right, so we'll do a bunch of writing code. I went on a little bit on that because I just like to impart a little bit about what this industry is like for people. When we're done with all that, we'll have a brief Q&A We'll tell you some data about our coding boot camps for those of you who are interested. And we do have a really cool free gift at the end. So that's our agenda. So briefly, who's the Tech Academy? We are a technology training company. And the way we impart that training is through what are called boot camps. Now, even today, there are some people that don't know what a boot camp is. When we started in 2014, there were only a handful of boot camps in the country. They were very new. But boot camps are intensive training designed to impart current skills in technology to prepare someone for immediate work in the technology industry. They're intensive tech training is what they are. We have a bunch of programs. We call them certification programs, and we'll cover more of them in detail, but they're cost effective. And most importantly, they are self-paced, which is a real big differentiator. More about that later on. One thing that's real important is we focus on what the industry needs, in-demand skills that'll give you both employment really rapidly and a long-term successful tech career. Our tuitions are under the national average. They start at like $5,300 for a boot camp, which way under the national average. And I want to read this next part verbatim because it's so important, which is why are we even here? What's our mission statement? The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. That's what we're all about. Our product is you working in technology. All right, so for those of you who want more information about the Tech Academy, I'm going to pause for just a second here. If you go to this link, Regina's put it in chat right now. If you go to this link, you can find out more about who and what we are with a quick little contact form. I'm going to pause for about a minute for anybody who wants to fill that out right now. And then when we're going to move on to the actual training, our first item on the agenda will be some basic definitions that will hopefully clarify some stuff for you. So grab that link if you want to. And I'm going to have a little bit of water. All right. So basic definitions here. The first one is, what is a program? Now, there's a real important distinction here. When you, as a consumer of a computer, use a program, you view it a little bit differently than the way a software developer views it. From the point of view of a user, a program is just really this just little icon that you can click on your desktop or wherever, and it'll start up this little interface for you to work in. Like you might start Microsoft Word, and it pops up the little editor screen, and you start typing in your Word document. You're doing word processing. When we say program, from the point of view of a software developer, what we mean is the instructions that we enter into the computer that make that kind of work available, that make that kind of work get done, that create the actual place where people can type in their text, for example, in a word processor. The program is you telling the computer what to do to make those functions available to end users. So it's a different view on the concept of a program. And really, it's the point of view of someone who is the driver rather than the passenger. It's the creator rather than the consumer. And I got to tell you, that's one of the funnest things to look at in terms of whether you're going to get into coding or not is, do you want to be on the business end of making the thing rather than the person who ends up having to use the thing that someone else created? It's really cool to be on the creative end of things. Another term to look at is programming languages. Well, if we said that we're going to enter instructions into the computer to make it do work, these are the instructions. These instructions are made up of words and phrases and symbols. You're going to see a lot of them tonight. These words, phrases, and symbols, they let you communicate with the computer and tell it what to do. Now, again, a consumer of a computer program would never see these words, phrases, or symbols. You see them as the creator of a program. And those words, phrases, and symbols come collected in a big body called a programming language. The language tonight is JavaScript. Now, the action of entering those instructions into the computer is called coding. That's a verb. Coding is you sitting down, and you're going to do it in just a few minutes. It's you sitting down as a programmer, opening up a little text document and entering in some instructions. That's coding. And the end result of you entering those instructions is the computer does work. Code is the instructions you actually write. So you're going to write code, and you are doing coding. Just to clarify some terms. All right, so let's talk about JavaScript. Now, JavaScript is extremely popular right now. And I want to clarify something, because if we were having this same class, say 10 years ago when we started the Tech Academy, I wouldn't be teaching it. I wouldn't be teaching JavaScript, because even 10 years ago, JavaScript was laughed at by quote unquote serious software developers. It was very limited in functionality. It was only designed for a very specific use case, and it wasn't taken very seriously. Beginning in about 2015, that started to change. I'm not going to go into the long history of how that came about, but I'll tell you what, I'm a convert. JavaScript is a very good language. It's very powerful. You can do a lot of things with it. And the original reason it was created is still around, which is to make websites have a lot of extra functionality, but it's gone way beyond that in the last 10 years. You can write full-blown awesome programs that have nothing to do with the web in JavaScript. So this is what we're going to talk about tonight, is JavaScript. So another language you're going to look at is what's called HTML. It stands for Hypertext Markup Language. Now, on our boot camps, you go into the full derivation of that term, what each element of hypertext markup language means. But it's enough for right now just to tell you that it's a computer language that describes how a web page is going to look, what's going to be on it, what are the headlines and paragraphs, and what parts are bold and what parts are italic, and where do the images go and where do the videos go. That's what you control with HTML. A related technology is called CSS. It stands for Cascading Style Sheets. This is another language that you use, and what it does is it works not just on a single web page, but it can apply to huge collections of web pages. And you can use it to control the appearance of the text and images and video, etc., on large collections of web pages. For example, let's say that a company has a brand new color scheme, big company, big corporation, and they change their branding a little bit, and all of a sudden they have a brand new color scheme. They can go into one computer file, and with a few instructions in this language called CSS, make a couple of changes, and all of a sudden every page on their entire website, click, changes instantly to the new color scheme. It's a pretty powerful technology. So these three technologies, JavaScript, HTML, and CSS, these are collectively known as the web languages, because they're the primary languages that you use in doing development related to the World Wide Web. All right, so there's some basic definitions. This is a JavaScript class. You're going to type some JavaScript code tonight, which is really cool. All right. Now, I would be doing you an injustice if I jumped into actually having you write code right now. And I want to take a second to explain that, because the last thing I want to have happen is you feel like, wow, this is a real bait and switch. Like Erik said that we're going to be doing a bunch of coding. Well, we're already, how long into it, and we haven't written code. There's a very specific reason why. And by the way, there's a specific reason why in our boot camps, we don't just throw you immediately into coding. And here's what it is. When you are using a computer programming language to create programs, there are only 5 elements of a computer program that you will end up using, regardless of whatever computer language you're learning, whatever computer programming language there is. There's only 5 things that any computer program has. And the fact is that once you understand these 5 things, every computer programming language is easier to understand, and your ability to think like a software developer increases dramatically. So we're going to take a moment and discuss the 5 elements of any computer program, regardless of computer programming language. And here's what the first one is the entrance point to the program. What I mean by that is, what's the first instruction that gets executed? Now, I could talk about each of these 5 elements for at least 15 to 20 minutes. They're that important, and there's that much nuance to them. That isn't what the purpose of this class is. So I'm going to give you some high level. There's a lot of reasons why we need to know what the first instruction is in a computer program, but the fact is, every program has to have one. The other element that every computer program needs to have is what are called control and branching instructions. This is a way to make decisions inside your program. The classic if-then kind of concept. If temperature greater than 80 degrees, then turn on air conditioner. Else, don't turn on the air conditioner, right? We make computer programs to automate decisions that we can make as human beings. And every computer program needs a way to determine what to do when various conditions exist. Those are called control and branching instructions. Another element of any computer program is that it must make use of what are called variables. These are pieces of data that the computer program will use. And most importantly, the data can change. To clarify, that means 2 things. One, while the computer program is running, that data might change. And 2, if a computer program has been off and then you turn it on again and it grabs data to work with, that data may be different than the last time it was open. An example would be the number of students enrolled in a class. While you're using a computer program to track that, the number might change as people enroll and as people leave the class. You've got to have a way to keep track of data that changes. That's called variables. The fourth element of any computer program, and arguably one of the most powerful, is the concept of what are called subprograms or programs within programs. If you can think of a whole program as a series of instructions, one after the other, that the computer is going to do in order, now think of a small set of instructions that you may want to repeat many different times within the greater overall program. That's what a subprogram is. And we could talk about this a lot, and you're going to build some of them tonight, but they're very powerful. And the final element that any computer program has to have is it needs to have a clearly marked exit, a clearly marked instruction that basically says, I'm done running this program. Now, there's a lot of reasons why, and again, on the boot camps, we go into explicit detail as to why that matters. But every computer program will reach a point where it's no longer running, and the underlying operating system, like Windows or Mac OS or Linux, is then free to stop giving a bunch of resources to that computer program that was running and then release them for other programs to use. So those are your 5 elements of a computer program. And I'll tell you this, we're going to talk about JavaScript tonight. But if you had these 5 things firmly in mind as you studied any computer programming language, that study would go better for you. All right, so now we're going to get to coding. Regina is going to put this link into chat. I see it popped up right there. Grab that link and open it up in a new tab. The first thing we're going to do is get you set up well to be able to look both at my code and at your code at the same time. So grab that link, pop it up. Now, in terms of side by side, I want you to set up a split screen where I am on the left. In other words, Zoom is on the left side of the screen. And your code, the tab you just opened, is on the right. So there's little tips and tricks on getting this set up, right? On a lot of machines, you can actually just drag a window over to the far left of the screen and it'll occupy half the screen. And then you can drag another window to the right and it'll occupy the other half. Sometimes with Zoom, you need to minimize the size of the window, the size of the Zoom window to get to move it around a little bit. But I'm going to give everybody a moment to get set up where I'm on the left in Zoom, and on the right is that code editor that you just opened. All right. One thing that may help on the Zoom meetings on some machines, if Zoom is full size, you might have to go to this right where it says Zoom meeting, click on it, and the restore button there can make it smaller and able to be moved around. Okay. Here we go. Let's do some coding. This is awesome. Okay. Now, I want to explain a couple things very briefly about what you're looking at right now. On the left is where we would enter in our code. Notice it looks almost like English. On the right is where the output of our code is going to go. The game we're going to build in this class is called a memory game, where you have cards that are turned over. You can see them on the right here. And when you try to guess matches. So there's a bunch of images underneath, and you have to guess matches. There's 2 of each image. Now, here's what I want you to do before I even show you that. Just to get ready, I want you all, look at my screen right here. I'm going to highlight a section. I'm going to want you to delete that. So go ahead and delete it. Okay. Now, meanwhile, I'm going to prep to show you the actual game in action. But I want you to delete that section, and I'll tell you why in a second, but just delete it. Now, this next step, don't try to copy all this code. There's just no way, okay? What I'm going to put inside here right now, that's the full code of the game. You're going to get all of this code at the end of the class. But let's go ahead and run it. And now I have over here 8 cards. I'm going to flip over 2 of them. This one, that's a heart, and say this one. Oh, I got a match. Wow. Now I'll do this one. I got a club, and this one. It's a diamond. All right, this one. Ooh, there's a spade. Oh, I matched. This one, club, I think it's here. Yep, I matched it. So obviously these 2 need to match. So you see how the game works. And I got a little thing that says, you win, play again. That's what the game is. Kind of cool, kind of fun. And you only have a certain number of attempts. I think 10 attempts to make it go right. So that's the game. So again, we're going to go through aspects of this game. But having you build every single line of this right now, first of all, would take hours. And secondly, is a horrible way to teach the fundamentals of computer programming. So we're going to do something different. And I think you'll find this very valuable. Okay, so I asked you to go in here and delete what's in between script and /script. So go ahead and delete that so your screen looks like mine. And I'll explain what we're looking at right here. On the left is a web page. This is the actual text you would write in to create a web page. Now, I said the web pages describe the content on a web page. Oh, sorry, these web page files, these instructions, they describe the content that will be on a web page, its appearance, that kind of thing. But this code is written in a language called HTML. Shouldn't be a shock because it says HTML. And HTML, hypertext markup language, is really cool because it lets us insert actual computer programs into the web page. And where they go is in between this script, and it's called end script. That little section right in there, this is where we write code. Good. All right, so the next thing I'm going to show you is a tool built into your browser. Now, I don't care whether you're using Google Chrome or, Apple's Safari browser, whatever browser you're using, up to and even including Microsoft Edge, if you have to. They all have a tool built in. Hold on just a second. want to see if I can make this bigger for everyone to see. I think I might have to do Control plus, 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 plus. There we go. Hopefully that'll be a little bit more visible to everybody. All browsers have a set of tools built into them that help you as a developer. The way to get to those tools varies, but usually you can right-click on the page, watch me do it, and then you follow along afterwards. You right-click on the page, and in Chrome, at least, you go down to what's called, where are you? Inspect. And all of a sudden, notice a whole other thing opened up. The web page is on the left, and all this stuff is on the right. This is what's going on behind the scenes. Now, we could literally talk for about 5 to 6 hours about every single tool that's in here in developer tools, and you would all want to fall asleep. I want to show you one. Along the top, you will see a tab marked console. I'm rolling my cursor over it right here. When you click on that, you see a little blinking cursor, and this is a place where only you as the developer of a web page normally would have access to. A regular user isn't going to pop into this and look at it, so you can use it to make messages occur from your computer programs. And we're going to do that tonight. All right, cool. So next thing, the console log is a record of messages in this console. You can see a bunch of messages up here. Don't pay attention to them right now. It's something to do with this W3 Schools computer, web page. It's got some kind of weird little errors. I don't care about them, but it's enough to know there's some output here that's useful to you as a developer. We're going to use that for our own output, and it's called logging something to the console, making a record of something on the console. Let's actually do one right now. Everybody follow along and type C. Go make sure you're in between the script and the end script. You can see me typing CONSOLE. So that means we're going to use the console, put a dot, and then LOG for log. And then do an open parentheses. This part's important. You're going to want to hit double quote. Just to the left of your enter key, most likely, is a key that has a single quote at the bottom and a double quote above it. You want the double quote. So do that double quote. And then put hello. And then another double quote. And end parentheses. And a semicolon. And you have run your own, you've written your own JavaScript. Click on the run button and notice on the right, it says hello in your console log now. It's got some other stuff. Again, ignore that. That's just part of some bug with this website that we don't care about. But you successfully were able to print something out on the console log. All right. Now, right now, I don't want to look at that. I just want you to see that. We'll make use of it later on if we need to. Okay. Right now, go ahead and close that with a little X. All right, good. So here's what we're going to do is we're going to look at those 5 different elements of a computer program, and we're going to show you how to build, how to use those in JavaScript. We're going to use examples that will apply to our memory game. But the main thing we're going to learn is how do you do those 5 things inside of JavaScript? Now, here's what I'm going to show you is that when we talk about our quote unquote computer program, the program we're writing is everything in between script and end script. That's our program. So all right, second. Is my screen gone? Okay, good. Excellent. For a second, we had some messages that they couldn't see my screen. Okay, so I want to do something kind of interesting here. I want you to go into console.log and change it from saying hello to saying this is the first instruction. And leave that on the screen for a second. Type in this is the first instruction. Then go to the end of the line, right over here, after the semicolon, hit enter, and let's do another instruction. We'll do console, it's the console, .log. We're going to log something to the console like we did before. Open parentheses, and type second instruction. Then make sure you do your double quote, your end parentheses, and your semicolon. Now, we want to see the console log again. So right-click and go to Inspect. Get your console showing again. And then click Run. And look what we see. We see two messages. This is the first instruction and second instruction. That's what we'd expect to see, because we have these instructions in order. And I know that's rock dead simple. Here's a brief description of why we care about what the first instruction is. And you learn all about this on our boot camps. When you're trying to learn how a very complex computer program works as a programmer, when you're expected to work on a very complex, large program, it might have thousands of files in it with hundreds of thousands of lines of code. It's very valuable to know what the first instruction is that ever gets executed the moment you start that computer program. And the reason why is once you find that first instruction, you can step through the code, even in your mind. You can start stepping through the code and start to understand how the program works, how it does its job. Especially important if you weren't the one to write the program. And so that's why we care about the first instruction. All right. So we've covered what the first instruction is. Now let's cover this concept of variables. I'm going to give ourselves a little more room here. After these console.logs, let's hit enter. Hit enter twice, so we have a little bit of room here. And we want to create a variable. Well, in JavaScript, the way you create a variable is you first use the JavaScript instruction var. So do var and then a space. Variables need a name. You have to have a name for the data you're keeping track of. Well, we're going to be building a game where we guess whether or not two cards match. And the guess, of course, is uncovering them. So let's have a variable called guess number 1. Okay, good. And now we need to put data associated with this variable. It needs to have a variable. So when you want to give your variable some value, give it the data it's meant to hold, you use the equals instruction. This is a symbol. This is a JavaScript symbol, which means we've created a variable, assign a certain value to it. Put some data in that bucket, if you will. It's called guess1. Now, we're going to make that data text. So do me a double quote, and we'll type spade, S-P-A-D-E, end quote, and a semicolon. And now let's make use of that variable. Let's log something to the console that says your guess was, the card you uncovered was a spade. So let's do console, C-O-N-S-O-L-E dot L-O-G for log. Give me an open parentheses. And I said we wanted to say, so do a double quote, the card you turned over is A, and then do a space, and then a double quote. Now, we're not done yet, because look at this. Right now, based on what we know from our earlier little study a couple minutes ago, all we're going to print to the console is the card you turned over is A. And that's going to sound really foolish. But we want to actually include what the card that got turned over is. And we're saying that the variable called guess1 is the card that got turned over. So we can actually make sure that you are right at, one space after the A. Look exactly where my cursor is. I'm right after the A. Right arrow wants to go after the double quote. Hit a space and then a plus. Plus is a JavaScript symbol that you can use to connect two pieces of text. On the left, we have text that says the card you turned over is A. That's what the text says. The card you turned over is A. On the right, to the right of this plus symbol, we want the text that is the actual type of card we turned over. But instead of typing, don't type this. Don't type this. Just watch me for a second. Instead of typing, quote, spade, which would mean that we always say spade, we want a way to print out what the actual current guess is. So instead, right after the plus, we hit a space and we'd use our variable. We made a variable called guess1. So type GUESS and the number 1. And then we have an open parentheses way at the beginning of this. You can see the open parentheses right here. And we need a closing parentheses to end it off. And then we need a semicolon. Semicolons are used in JavaScript to say, this is the end of the current instruction. So I'm going to leave that on the screen for a second. I want you to run it. What you should see, and I'll pull it over here, is you should see what's in my console, which is the card you turned over is a spade. If you don't see that, look very carefully at what I've typed on these two lines and see if you've missed any characters or they're a little bit different. So why do we care about this variable? Why is this awesome? Well, let's say at some other point, hit enter right here. Let's say at some other point, the next guess was a heart. Well, let's say we're going to make guess1 have a different value. So type in guess, GUESS1. And then we'll give it a different value. So space and then equals. And now inside of double quotes, type heart. So what if it was different than spade? Now give me that same console log. console.log. Same thing. Let's type the card you turned over is A. And just do the exact same thing again. You're copying the line from 2 lines above. Plus guess1. You could literally copy and paste it if you want to. It's the same exact instruction. But when you run it, give everybody a moment to type that in. When you run it, first you see the card you turned over is a spade. Then you say the card you turned over is a heart. We have successfully made it so our computer program can keep track of a piece of data, in this case, the variable called guess1, and that data can change as the computer program executes, and the program will make use of it. That's kind of valuable. All right, so that's variables. The next thing we talked about is control and branching statements, the classic if-then. So let's look at if-then. Well, one of the things we're going to have to test all the time is, do we have a match? We turned over 2 cards. Do they match? So let's show you in a very basic form how you could do that. Again, go to the end of the last code line here and hit enter a couple of times to give ourselves some work or some room. And we already have a variable called guess1. Well, we need a second guess. So let's do a variable, var. You never guess what we're going to call it. Guess2, G-U-E-S-S 2. That's our second variable. So let's give it an initial value. So space and then equals. What do we say? We make it club, C-U-L-B. All right, so, and then a semicolon. We've now made a second variable. Okay, fine. We need to check to see whether these 2 guesses are identical. Now, you and I can look at it right now, and we know they're not, because we can go up here and say, well, guess1 is equal to heart, because that's the last thing we did with the variable called guess1. We made it equal to heart. And guess2 is equal to club. So we can look at it and know they're not equal. But we also know that we made this program so that these are variables. They can change. So we need a way to check whether or not they happen to be equal at any exact point in time. So hit enter again to give yourself another line. And let's build our first controlling statement. It'll control whether or not one of 2 different paths are followed. Just like you come to a fork in the road. The instruction inside of JavaScript for this is, not surprisingly, if. When you use if, and this is true for almost every single computer programming language, when you use if, when you're going to force the computer to make a decision, you type the if command, and then in parentheses after it, you put the thing you need to check whether it's true or not. Because if it's true, you do one thing, and if it's false, you do another thing. So the first thing we're going to check, we're going to do our open parentheses, and we want to see whether or not these 2 guesses are the same. So let's type out these 2 variables, guess1 and guess2. So G-U-E-S-S-1, and then a space. And now this part is really cool. There's a special instruction in JavaScript and in most computer programming languages to check whether 2 things are equal. And that is 2 equal signs. This double equal sign, that checks whether or not things are identical to each other. And you just can put one on either side of it, and the computer will determine whether or not they're equal at the moment it happens to run that instruction. So we put those double equals, give me a space, and then type in the second variable, G-U-E-S-S 2. And then you can put your end parentheses. And look at the way this reads, folks. It reads almost kind of like English. We're saying if guess number 1 is equal to guess number 2, well, then what do? You put the what do we do inside of curly brackets. Let me show you exactly how that's done. Okay. Give me a space. And then you'll find the curly bracket in and around, around the enter key above the square bracket. So you hit shift and that key that has square brackets. And now I have a curly bracket. You see that? Hit enter. Now I'm going to teach you a very valuable trick or tip as an instructor. If you have put in a curly bracket, you've got to have a corresponding end curly bracket. So my recommendation is always type the end curly bracket immediately after you type the beginning one. So I'm going to immediately hit enter twice. Boom, boom. And I'm going to type my end curly bracket so I never forget to have my curly bracket. I cannot tell you how many times I've had code that wouldn't work, and it's because I missed a curly bracket. It's a common joke amongst engineers. So I've typed it, but now I'm going to go back up with my cursor. I'm going to go back up. Now I'm inside these curly brackets. Inside this curly bracket is what you put that's going to be done, the instructions to be done if guess number 1 is equal to guess number 2. In other words, if the condition inside these parentheses is true, then we do the instructions in between the curly brackets. So we're controlling the flow of execution of this computer program. We're controlling which path of the paths that we built, we're controlling which one gets taken. So what do we want to do? Well, in this case, what we're going to do is we just want to say you found a match. When you see the full program, there's a lot more that'll be done, but we're going to keep this simple. So I want you to hit space a couple times just for readability. And then we're going to do a console, CONSOLD .log. We've done this a few times now. Open parentheses and a double quote. And we're just going to say, you found a match. You found a match. And then an double quote, end parentheses, and a semicolon. Why are we going to print that? Because if the two guesses are equal, it means they picked two identical cards. Now, we may do something different inside the full computer program, and we will. I'll show you that. But for now, we just know that there's a separate set of steps to be done if they match, and another set of steps to be done if they don't match. So let's run this code. Let's pull the console back over so we can see what's going on. And I'm going to run my code. And nothing happens. Why didn't anything happen? I just got the same results I had before. I got all the results from my earlier code. I printed, this is the first instruction, second instruction. The card you turned over is A. Why did we not get anything here? Well, there's a super valuable teaching moment here. We did not provide any specific instruction to the computer on what to do if these two variables were not identical. And because we didn't clarify what to do, the computer chose to do nothing. But they're not equal. It checked. I guarantee you it ran this instruction and it checked whether or not the variable called guess1 was equal to the variable called guess2. They weren't, because guess1 is equal to heart and guess2 is equal to club. And so it did not step inside these curly brackets right here and execute this instruction. Well, what do we want to have happen if they don't match? Well, let's do that right now. Right after the square bracket, the curly bracket, hit enter. And we're going to use a corresponding JavaScript instruction called else, E-L-S-E. This is what to do if the first thing isn't met. If the first condition right here isn't met, now we're going to tell it what to do if you don't meet that. And the instructions to be done will again be inside curly brackets. So give yourself an open curly bracket, hit enter a couple of times, and give yourself a closed curly bracket, just like we did before. And then go right in between them, hit space a couple of times just to make it a little more readable. The spaces don't affect the computer program's execution, just makes it more readable. And now this is where we put, when I say this, I mean inside these curly brackets, this is where we put the instructions to be done if we don't have a match. We're going to keep it really simple and just print something to the console that says not a match. So give a console.log. We've done this a few times now. Open parentheses, double quote, and type not a match. And then double quote, and parentheses, and a semicolon. When you've done that, now run your program. And look, we do get a message that says not a match. We have successfully controlled the direction of our program. I know it's really simplistic. I'm keeping it simple just so you can see the basic concept illustrated. When you're building a much more complex program, there might be a lot of steps that get done when we have a match, and there might be a lot of steps that get done when we don't have a match. The fact that there isn't a bunch of steps is unimportant for learning the fundamentals of how the computer programming language JavaScript works. And this applies to any language you're going to learn in the future. Start with very simple examples. Just learn how to control the flow of the program. How do we get our program to make decisions? We have successfully made the program make a decision based on whether or not the two guesses match. Well, let's get a match and try it. I want you to make guess number 2 equal to a heart, so that make sure you spell it exactly the way guess number 1 is spelled. And now when you run the code, it says you found a match. So we tested that we can successfully run this branch of code, and we can successfully run this branch of code based on whether or not we have a match. Now, again, I know it's a really simple, kind of made-up example, but this is powerful in writing computer programs. You get to have your computer program make a decision based on criteria that matter to you for whatever business case you're trying to solve. There's some feature you're trying to implement. There's some very real problem you're trying to build a computer program to solve, and that will almost always involve making decisions. And based on the result of that decision, you've got 2 or more different things you could do. And you are now able to control doing one of 2 different things based on a condition. That's powerful. All right, the last thing we're going to cover here, before we show you the full code and give you a little bit of tour of it, is what we call the subprogram. This is really fun. Now, you can probably imagine that we're going to want to check whether or not we have a match several times when someone's playing the game. In fact, when you saw me demonstrate the game, you saw that we're going to give them up to 10 attempts. Let me tell you something. You don't want to be typing this exact code 10 different times for a lot of reasons. One of the things you'll learn about on the boot camps is why you don't want to repeat yourself with code over and over again. There's a number of very important reasons. But just based on all that typing and the possibility of making a little bit of an error each time you try to type the same thing over, I think you can imagine we don't want to type this 10 different times for every single guess the person is going to make. You have a perfect candidate for what's called a subprogram. Remember, I called them programs within programs. They are small chunks of code. In other words, small sets of instructions that can be used on demand when the main program needs them. That's a perfect candidate for it. We're going to have to check for a match over and over again. So let's make a quote unquote subprogram that can check whether or not a match exists. In JavaScript and in many different programming languages, the term that's used for a quote unquote subprogram is a function. So we're going to make a function, which is a set of instructions that can be used over and over again on demand. So go to the end of your code here, right after this curly bracket, see where I am, hit enter a couple of times to give yourself some room, and let's make a function. In JavaScript, the way you make a function is by first using the JavaScript word called function. This is called a keyword. It's a language that you can only use for the JavaScript language. You can't use it for your own like variables or anything. We're going to type function, and now you need to give your function a name. We're going to call this one, now I'm going to capitalize the first letter of each word. We're going to call it check for match. I'm going to capitalize capital C, H-E-C-K. Now for, capital F-O-R. And then match, capital F-A-T-C-H. Check for match. Nice descriptive name for our function. This is, it's immediately, obvious what we're going to use this for. Here's a fun part. Now, again, on our boot camps, you go into a much deeper dive on this. One thing to know about these subprograms or functions is that often when you do need them, you need to give them some data in order for them to do their job. In this specific case, we want to give it two different guesses, two different cards that have been turned over. And its job, the job of this function is, given two different cards, to tell whether or not they're identical, to tell whether we have a match. In JavaScript, and again in lots of languages, when you are going to give the function some information to do its job, that information is called parameters, and they go inside of parentheses. So without hitting space, right after the word match, give me an open parentheses. And then we're going to make a little list separated by commas of the information we need to give. We're going to give it the first card, CARD1. Whenever we use this function, we're going to give it what card number 1 was, hit a comma, a space, and then we're going to give it card number 2, so CARD2, and then hit your end parentheses. You can start to see the way this reads is, again, almost like English. Make a function called check for match that takes in two pieces of information. The information is called card 1 and card 2. Okay, good. All right. Well, now we need to describe what actually happens when we use this function. You do that by writing out the instructions, not going to be a shock, inside of two curly brackets. So give me a space, hit your opening curly bracket, hit enter twice, and give me your closing curly bracket. You've seen this pattern a couple of times now. And then move your cursor up and hit space a couple of times, again, for readability. We know that inside these curly brackets, we need to list out what we want to do every single time we have to check for a match. Well, all we're going to do is take the same basic pattern that we used up here and use it again. So we need to check if the information that was provided, something called card 1 and something called card 2, check if they're equal. So type an if, and you know that what's after the if is the condition, and it goes inside of parentheses. So we say card 1, and then a space. The double equals checks for equality. So a double equal, then a space. You can probably guess it's card 2, and then end parentheses. Now I want to clarify here. When we use this function, the information that it receives will be called card 1 and card 2 for the purposes of whatever's inside these curly brackets. It came in being called card 1 and card 2, and so that's what we're working with. So what do we do if card 1 and card 2 match? Well, we put inside curly brackets, so space, open curly bracket, enter a couple of times, and a close curly bracket. Hit space a couple more times. This shouldn't be a shock to you. We're going to do the same console.log that we did before. Do console.log in as you found a match. Console dot. See if I can learn how to type. .log. You found a match. And then double quotes, and parentheses, and a semicolon. Again, same pattern we had before, which means that we need an else. So go right after the end curly bracket right here, hit enter, and give me an else. And then another set of curly brackets. So a space, and then open curly bracket, enter twice, a close curly bracket. It's the same pattern. Go up and then hit space a couple times. And now what do? We're going to print to the console, not a match. Console.log, parentheses, double quote, not a match. And then, double quote, end parentheses, and a semicolon. Now, we have built a function. I'm going to illustrate two really cool concepts here because we have time for it. Everybody pay very close attention to what I'm going to do right now. This whole chunk of code that we were first experimenting or learning about control and branching statements, this if, I'm going to highlight it. I want you to highlight it too. Pay very close attention. Don't highlight anything else. just from the if down to right after this curly bracket, and I want you to delete it. Boom, it's gone. Make that go away. I'm doing this for a very specific reason. I want you to run the code now. And this is really a very important concept. Notice the output. We've got this is the first instruction. It's right here. That's not a shock. We have second instruction. Shouldn't be surprising. We have the card you turned over is a spade. Good. We have the card you turned over is a heart. Good. But we aren't printing anything about whether or not we have a match or not. For some people, for a lot of people, when they're first learning to code, that might be kind of confusing. We've written some instructions here to check on equality. If it's equal, we're going to print something. If it's not equal, we're going to print something else. Why isn't that happening? And again, this is super important. This thing I'm going to highlight right now, this function we created, it is not something that is going to be run in your program until you tell it to run. The process of doing that is termed calling the function. All we've described here, and this is the critical point, folks. This thing that's highlighted right now, this function, is potential behavior. A set of instructions, a set of computer instructions, programming instructions that could occur if we asked them to. That's all it is right now. And we have not asked it to do anything. We haven't asked it to run. And that's why there's no output from this in the console. We never even asked for this to occur. This function, this called check for match, we didn't ask it to run. In other words, we didn't call this function. That's what the terminology is in computer programming. When you ask for a function to be run, a subprogram to be run, you're calling it. Well, let's call it. Go down to the end after the last curly bracket. It's right here. And let's call the function. You do that by just entering the name of the function. Make sure you type it exactly the way we named it. We named it check for match. Type it as check for match. Capital C, H-E-C-K. Capital F-O-R. Capital M-A-T-C-H. So type that out. Do not hit space afterwards. Because I said earlier that sometimes when you have these functions, these subprograms, they need some information to do their job. And ours is certainly no exception. It needs 2 different card data items, 2 different guesses. So hit your open parentheses and let's give it 2 different guesses. We happen to have 2 of them. One's right here and one's right here. It's these 2 variables we made. So we can put these variables in as what are called parameters, information being given to the function so it can do its job. So type in the name of the variable, GUESS1, comma, and space, and then guess 2, and then end parentheses. And that's the full instruction. So you can hit a semicolon to end it. Now we're asking it to run. So go ahead and run it and see if it changes what's in your console. You found a match. Why? Because at the time that we actually called check for match to run, guess number 1 was equal to heart, and the variable guess number 2 was equal to heart. So give everybody a moment to catch up. Just a second here. And I've only got 2 more points to make, and then we're going to look at the whole program, the full program. So the whole point of variables is we want to work with data that can change as the program is running. Well, certainly the two guesses by our player are going to change over and over again. So let's simulate what that looks like. Go to the end here. We're right after the semicolon. And let's make a different combination. Let's reassign. Let's give new values to the variables guess one. So we'll say guess one equals spade, semicolon. Now we've given it a different value. It was equal to heart. Hit enter. And let's make guess two a diamond. GUESS 2 space equals, quote, diamond, semicolon. This represents another set of guesses by our player. So now, having gotten two new selections, two new choices or guesses, we need to check whether they match. So hit enter, and let's call the function again. Capital C, H-E-C-K, capital F-O-R, capital M-A-T-C-H. We're calling the function again. We'll pass in guess one and guess two again. GUESS1, GUESS2, end parentheses and a semicolon. There it is. Run it. And now you get not a match, which they certainly aren't. So I just want to illustrate here the power of creating this subprogram called check for match. It means with one line of code, we can over and over and over again check whether there's a match. Instead of typing out these 7 lines of code, 1, 2, 3, 4, 5, 6, 7. Yeah, instead of typing out these 7 lines of code every single time they make a guess, we type out 1 line of code. That's a lot easier as a developer. And this is the last point I'm going to make. Let's say the game designers say, we really want to punch up the fact that they didn't have a match. We want an exclamation point after not a match. Because we have a function called check for match, we can go to one place and add in an exclamation point. We made the change we want, and this change now is reflected every single place we call on check for match. It makes it much easier to maintain your computer program over time. Run that, and you'll see that now we have some exclamation points right after not a match. All right, so those are the fundamental 5 fundamental elements. Now, I didn't talk about the final one, which is an exit point. Some computer programming languages require you to explicitly put an instruction in to say, I'm done running this program. JavaScript does not. As soon as it's executed the last instruction that it's capable of doing, in this case, this instruction right here, as soon as it's done doing that, the underlying operating system, in my case, Windows, is informed, hey, I'm no longer running that program, so anything you were doing to help that program, you can stop. R. Anderson asked, what about the return command? The return command is used inside a function to say, pop out of the function. It doesn't say, end the computer program altogether. And that's something you learn to use in detail on the boot camps. That was a good question, right? And we may address a little more detail of it on Q&A later. All right. So now I want to look at the full computer program. So let me look at this, make sure I'm doing everything right. Okay, Regina, can you, first thing, delete all the code you've done so far. So literally Control A, like I just did, and then delete. Delete all the code in the code editor. Next, Regina is going to paste a link in there right now. You see it, okay? I'm going to click on it so you can see it as well. This will pop up. Select all of this code. Click anywhere in it and hit Control A, and then Control C, or Control C, there we go. Copy all that code, okay? If you're on a Mac, it's Command A, Command C. Copy all that code, go back to your editor, and then paste it in. Huge, long code. Now, you can close your developer tools, and I'm going to give you all just a second to play around with the game. Nothing wrong with that. It's a pretty cool game. If I can get this thing to, why is it not being friendly? All right, run the game. So play this. Guess some. All right. Club diamond. All right. There we go. Hearts. All right. Got me some diamonds. Got me some hearts. And there we go. Okay, good. So I won. And that's the game. Now, let's explain this code at a high level. And I just want everyone to just pause for a moment. We just went through a lot of stuff. We looked at the 5 fundamental elements of any computer program, and we learned what they look like in JavaScript. I'm about to show you what at first glance will appear to be a pretty complex program. We scroll to the top here and scroll down. There's a lot of stuff going on here right now, and there are comments in the code. You can see them in green. Those are to help you understand the code. We use these all the time as developers, but there's a lot of instructions. There's a lot of them. I do not want you right now to start diving into each individual line and trying to understand it. That isn't how I would do it as a developer. I'm going to show you how I would look at this as a developer. I would be thinking with, first of all, what's the first instruction that gets executed? And let me show you how to think with that in this JavaScript. I go to the top here and I go all. Well, all this stuff is HTML. That's just laying out the web page. That's not an instruction. It's not my code. In fact, I mentioned this earlier. Your code is going to go inside the script section. So let's scroll down until we find the script section. I want everybody to start looking for this too. And look, we found it. Here's the script section right here. Now, I want to know what these first instructions are. Okay, well, here they are. Look at this. A constant is another type of variable. Okay, I know the name constant sounds like it wouldn't be changing, but there's some odd stuff in JavaScript. It's valuable, but there's a thing called a constant. You'll learn about that on the bootcamp. Think of it as a variable. That's fine. But what's more important is it contains a set of symbols. And those sure look like the symbols of a deck of cards, don't they? All right, good. So you would see immediately, I've got some symbols to use. Oh, I've got some attempts. We'll give people 8 attempts. They start out with 0 matches. We have some collection of cards that they flip. Oh, yeah, okay. I'm going to flip 2 cards at a time. I better keep track of those cards. And so on and so forth. I'm setting up a bunch of things. It even says initialization of game symbols, the counter of how many attempts, other variables to keep track of the state or condition of my game. Okay, so it's a bunch of setup here. And then, oh, look at this. Now I get done with that and I start creating functions. Remember, functions do not execute until they're called on. So I have a function called setup game. All right. Make my cards, put them on the game board. Got it. I could dig into that in detail if I want to. Well, let's go down to the next function. Oh, look, there's a function when I want to flip a card. Because remember, you can click on one of these bad boys and it flips. That's the function that handles that. Again, we're not going to dive into all the nerdy detail on exactly how this works. Just know I needed to build a function to handle that, right? Then there's another function down here. Check for a match. Hey, that sounds awful familiar, doesn't it? Now, this is a little more complex, but I want you to see we have an if for when they match and if they don't. Look at that. We've got some equality here. Now, again, it's 3 equal symbols, which is it's a slight nuance on equality. You'll learn about that on the bootcamp, but it still means check whether or not they're equal. I've got, is this symbol equal to that symbol? So you can start to read this code. Yeah, there's more data in here than just the simple is variable 1 equal to variable 2. There's more data in here, but it's the same concept. One of our graduates should be able to read through this whole thing and understand all the code, but the high level things we just went over should be standing out to you. More functions. How do I disable the cards? And how do I unflip a card? How do I reset the board for the next turn? How do I check whether or not the game is over? Right? Ooh, I've got 4 matches. Well, that means the game is over. Or I don't have any attempts left. That means the game's over. Okay, good. I got it. Excellent. How do I reset the game and start a new round? And then finally, this is really important. Check this out. This is really critical, and then we'll be wrapping up. We have a bunch of actual instructions. So I'll go back up to the script. Everybody go back up to where script starts. We have these like 8 to 10 instructions that get done right off the bat. A bunch of initialization instructions. No other instructions happen for a while. All we're doing is setting up functions. Function, 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 function. And then finally, we call on one of the functions. The setup game function. This is how you could start to dig into a computer program that you'd never worked on before and you were expected to be a contributing developer on. You'd find what instructions happen in what order, and you'd find this big call here to call on the setup game function, and then you would go straight to that function, setup game, and you'd start going through it. Oh, and this is where you would start to really dig into the logic. You wouldn't start with any of the other functions because they don't get called first. Okay, good. So, a lot going on there. Give me just a second to I lost one of my Zoom controls. Give me just a moment. All right, I'm going to stop sharing, get this running again. I apologize. Okay, good. All right. Share my screen again. Okay. So I'm looking at the time here, and I want to maybe take one Q&A. Regina, do we have a good question in the Q&A in the chat?
See. There was a couple earlier, but there is one that says, what about adding sounds to match the cards?
Ooh, love that. Love that. Okay, good. There's a teaching moment here. Okay. There's ways to make sound with JavaScript. Okay. I don't actually happen to know the exact like instruction and the right way of writing it. And that's not because I'm stupid. Well, there are people who would argue that. And here's the teaching moment. The exact syntax, i.e., the words and symbols inside a computer programming language and the rules around how they have to be sequenced, that's syntax. The exact syntax of certain instructions, it's utterly unimportant to memorize any of that. Some of it will become part of your memory just because you use it a lot, okay? Other parts, you're not going to remember, and that's not bad. I bring it up because many of our experiences in education have, rightly or wrongly, stressed like remembering a bunch of things. You get tested on it. You remember this and that and this date and with the Battle of Hastings in England and all this stuff. Like in programming, we don't care about that. It's more important that you understand the fundamental principles and then can look it up. We get paid to Google things. It's not a joke. We get paid to Google things, but we know what to Google. So as an example, let's have fun with this. I would just say JavaScript make beep sound. That's it. How to make JavaScript beep. Oh, there's some code. Now, I'm not going to dive into this because I happen to know it's got a bunch of real complex terms. Okay. One of them is you could actually get an audio file of a beep and you can cause it to play every time. And there's other ways. Okay. But the point is this. One, that's a really cool idea. I actually love that. Make a beep when you get a match. Second thing is, if you just know the rough way to start poking around on the internet for it, then you can find the right code example. There's a lot more to it, but it is one of the things we stress really heavily in the boot camps is learning the fundamentals so well and learning the places and approaches in finding the information you need that you can self-teach when you're a graduate. Any new changes in technology, you can figure them out really quickly. Any challenge you're facing on the job, you can Google it well. And honestly, with ChatGPT now, you can ChatGPT it really well. It's pretty cool what can be done. All right. I hope that answers that question. That was a really good question. I appreciate that. All right. So let's go back here. Okay. So. Okay. You are going to get an opportunity to ask more questions, by the way. We're going to give you an opportunity to email in a few moments for a free gift. You can add in questions we didn't get a chance to get to, and they'll get forwarded to me, and we'll answer them. All right, so let's talk briefly about who, the boot camps we have, what we're all about, right? You can see 12 different symbols on here. These represent the 12 different boot camps we have. We have online boot camps. You can do them on premises at our Portland, Oregon campus, but most students do it online. They cover a huge range of technology subjects from artificial intelligence, you see down here, computer programming, website development, video game development, which is great, cybersecurity, design, data science, mobile app development. They cover a wide range of subjects. In fact, we have more programs than any other coding boot camp on earth, more certifications. I also want to describe like the characteristics of our boot camps because look, everybody knows, every company, every boot camp probably justifiably is proud of certain aspects of the program. There's a few key things that we are very proud of. One is that these programs are self-paced, but you also get instructor support. That is a really challenging thing to do, and we do it really well. It means that you can go through these programs at your learning pace, not having to stay in lockstep with a big group of students who are all studying the same things on the same day. That's very valuable because there's some things that you're going to take to really quickly and some things will be more challenging, and you're given the time to handle both. The programs are really flexible. Students set their own schedule and they can enroll any day of the week, any day of the month, 365 days a year. You can start anytime you want. Our content is really, really well-rounded. It's in depth. It's not a light cursory covering of a lot of subjects. Yeah, we've got 4 or 5 months, depending on the boot camp, to get you through. There's a lot of variety in terms of how long they take. We can't teach you everything, but when we do teach you something, we teach it well so you understand it and you know the principles behind it and you can think with it as an engineer. The boot camps are really affordable. Like I said, as I said earlier, they're priced well below the national average. And we're proud of that as well. And we also offer a lot of different financing options, from upfront discounts to monthly payments, right? There's a lot of variety there. This part's critical. All of our programs, all these live boot camps, they also include job placement training and assistance. This is critical. It's one thing to learn the technology of software development. It's quite another to learn the technology of how do I get a job in tech? They're two different things. We teach you both. There is an actual course on getting a job in tech and dedicated, experienced job placement professionals that help you after that. Most importantly, all of these programs are designed for absolute beginners. No prior experience in technology or coding is required. That's really valuable. The fact is, if you can read, write, and do basic math, you can get through these programs. And who are these programs for? These are for anyone who's looking for a better career. Technology is a great industry to work in. I'm very proud of the industry. Yeah, there's aspects of it because it affects so many, elements of culture that need help, which is all the more reason for really good people to move into the industry. Another really cool thing is lots of remote work opportunities. That's not always true. There are jobs that they literally can't be done remote. Technology can, which is kind of cool. This also means there's better work-life balance. And it's very true. I've worked in tech for a long time. It's really good work-life balance. And it's not all about money, but tech pays really well. It really does. It's pretty cool. So that's our boot camps. Now, and just so you know, it's not just us talking about how awesome we are. These are some of the awards and recognitions we've got. We consistently land on the best of lists from every major objective provider of those rankings. And this is what our graduates and students have to say. If you look across all the different places you can leave reviews, whether it's Google, which is, everybody can access that, or these very dedicated boot camp industry sites like Career Comma and SwitchUp, we've got an average of 4.8 stars out of 5 across all of these review sites, and we're very, very proud of that. So if you'd like more information and a free coding bootcamp guide that'll help you figure out, okay, good, so I want to go in tech. What's the right route for me? There's so many different options. What makes sense for me? The coding bootcamp guide can help, and it's free. So if you go to this link that Regina just dropped into chat, learncodinganywhere.com/Erik, just fill in a simple contact form. We'll get you that guide, and you can find out more. Look, we know that not everybody who attends these classes, it isn't the perfect fit for everyone. But if anything about how we taught tonight appeals to you, and if anything about like learning to code and work in technology appeals to you, just check it out. If there's a fit there, I think you'll love our programs. So I'm going to pause for a moment, let anybody who wants to grab that link out of chat, go in there and fill out the form. It takes just a second. And if you go to that form and you get taken to a login screen, all it means is that at some time in the past, you already filled out the form, and there's credentials. You can see what to use for the credentials at the bottom of this slide. But I'll pause for a moment for people to fill this out. Awesome. Okay, cool. So stick around because there's a really cool free gift coming your way. Okay. I do want to tell you about something really cool. We have a referral program, and the reason why is that our graduates, they're really, really happy with us. They love us, and because of that, referrals are one of the top sources for enrollments. But it's not confined to just graduates of the program. You can actually use this program to do too. We pay a 5% referral commission for anyone who signs up because of your referral. So in a moment, we're going to ask you to email in to get your free gift because we send it out to you, right? If you have someone you think would be a good fit for this, or we should be talking to them, put their name and contact data information in there. We'll register you as having referred them, and we'll pay it out. We pay out every week referrals. It's great. We're super happy to pay it because it means a lot to us. You respect and trust us enough to pass that on. So take advantage of the referral program. It's pretty cool. Now, we've published 6 books and a dictionary over time. We worked really hard on these. Okay, we have 3 Learn Coding Basics in Hours books. We have a coding book for kids and young adults. We have a Technology Basics Dictionary, which is super valuable, a Project Management Handbook, and we've got a book called You Are Not Stupid. I want to expand on You Are Not Stupid. This book rocks. Obviously, Jack and I wrote it. I'm not going to You can take that with a grain of salt, but you really shouldn't. Like, here's what was missing. And I looked for decades for this and found things that came kind of close, but never really nailed it. This whole subject of technology and computers can, at first glance, appear to be very complex. There's lots of moving parts. There's thousands of terms. And it's got this deep history, and probably most frustrating when you look at the outside of a computer, like your mobile phone or a laptop or a desktop, you can't see anything inside. And frankly, the pieces inside there that are doing all the work are literally so small you can't even see them with the naked eye. There's lots of challenges to make full understanding of technology and computers easy for people. And we sought to solve that. Now, on our program, the primary way we solve that is with the very first course that every boot camp of ours has, all 12 of them. It's called the Computer Basics course, and it's amazing. We took all the content in there to remove the mystery from computers and technology and expanded on it and put into the book called You Are Not Stupid, up to and even including all the history of how we even arrived at the point where these digital computers work and are so influential in modern society. Everyone should read this book, not kidding. So that's You Are Not Stupid, or YANS. Obviously, we're real happy with that. It took about a year and a half to write. So we mentioned a free gift. This is your free gift. It is our Learn Coding Basics in Hours with JavaScript book. This thing is really, really cool. A couple things about it. Yes, you're going to learn the fundamentals of JavaScript. Also, you know those 5 elements of computer programs that I added onto? I said there's more we could talk about. We expand on that in this book, so you'll learn those even more. If you want your free copy of this book, just use this email. Virginia just put it in the chat. And send in, this is important, make sure you include your mailing address. Every once in a while, we get someone who just says, okay, good, I'd like one. We're like, oh, we need to send it to you. So put your mailing address in, okay? We'll send you a copy of the book for free. And again, here is where you can put in 2 other things. If you didn't get a chance to get your question answered and you'd like to ask a question, put in whatever question you have tonight's coding class, and it'll get forwarded to me. We'll get you an answer. Secondly, if you have referrals, and we encourage it, we do pay these commissions, and again, we're happy to put the your referral names and contact data in there, and we'll get a hold of them. And if it works out, you get 5%. So I'm going to wait a moment for anybody who wants to grab that email and send something into us to get the free gift, or has a Q&A, or wants to make a referral. All right. Now, we would like to be able to interact with you, and we want to be able to make it easy for you to interact with us. We use this service called Linktree. There's a link to it going into chat right now. There it goes. And if you haven't used Linktree, it's just a collection of all your different social media connections and links to all your major sites. What you'll find here are links to our free YouTube playlist with all of our educational resources. You'll find a link to our books and our dictionary. You'll find links to our upcoming meetups. So if you're interested in future classes that we deliver for free, check on there. It's all on Linktree. All of our social media accounts are on there. So there's 2 asks that we have for you. If you're getting any value out of these classes, we'd ask you to do 2 things. They're free, and they would be very helpful to us if you would do it, and we'd appreciate it. 1, please follow us on social media. Be the first to hear about different things we're doing, right? Secondly, invite your friends to these classes. And please tag us on that. Now, here's a very specific thing. Regina's going to put a link in the chat right now, and it is a link to the next event we're having. I just saw it in chat. If you would like a chance to win your own copy of You Are Not Stupid, here's exactly what we'd ask you to do. You don't have to. We'd ask it, and we'll be able to, like I said, we're going to do a raffle each week to win a copy of You Are Not Stupid. It's simple. If you will share that link to the next event on your social media, Facebook, Instagram, X, wherever you're going to put it, if you'll share that link and tag the Tech Academy, because we're on each of those platforms, if you share the link and tag us, we'll enter you in to win a copy of You Not Stupid. This is, I think it's $25. We'll be glad to send it out to you. just as a gift for being able to at least let other people know about this. Don't do it if you're not real happy with what you're doing, with what we're doing. But I would wager that you got some value out of this. And if you got value, please help us to get in contact with more people. And again, we'll announce the winner at the next event. And there you go. So, your next steps. Again, you can go to this link to find out more about us. If you already clicked on this link, make sure that you fill out the form, the form on it, and do the next steps. It's a really cool process. You get to go through at your own pace and find out everything about our programs, what kind of fit in technology might be best for you. It's an educational process and very, very helpful, right? And finally, please come to the next event. We'd love to have you. We got a couple of really cool things coming on. There's a coming up. There's a ChatGPT event to be able to be better, more skilled at using ChatGPT that I'll think you find very valuable. This is training that's been real, like exclusive and behind the scenes. We're opening up to everybody right now. It's very, very good. And we're going to have, in the very near future, a day in the life of a developer training where we just talk about what it's actually like to do this job. I mentioned a couple of misconceptions, like that you would spend all of your time typing, whether you have to type really fast. We're going to break down what's the job actually like. I also mentioned that only about 25 or 30% of your time is actually spent coding. What's the other 75% spent doing? What do you do? Sit in the basement eating Cheetos? Maybe if you want to. But in all seriousness, we'll talk about what it's like to actually do these technology jobs. So join us for those. Thank you all so much for attending. I super appreciate it. I'll stick around for a moment to see if there's any other little questions that come in Q&A. You're welcome, Aksum. I appreciate you being here. Okay. Yeah, I'd love to see you at the next event. And thank you all for attending. I'll sit tight for a minute and wait. You're welcome, Myra. Thank you. Absolutely. Thanks, Job. Okay. Appreciate it. Absolutely. Really good to have you in from Atlanta. Okay, cool. Excellent. Thanks all so much. Appreciate it. We'll see you at the next event.